All right, on page 2 of the solving trig equations, I want to do problem 11 and problem 12. They are the ones that are going to stand out the most out of everything that we're doing. So I'm going to zoom in on number 11. And again, I have my paper in front of me that has all the information for my trig chart. And here's what I want you to recognize. We have a small problem here because we have both cosine squared and we have a sine equation. All right, that's going to cause some concern. I am going to move everything to one side because it is cosine squared. So this is going to be 2 cosine squared theta minus 13 sine theta plus 5 is equal to 0. Now, there's no way for me to factor this as it's written. So what I want to do is get this whole equation into terms of sine. Now, a long time ago, galaxy far, far away, I don't know, 2 units ago, we talked about a Pythagorean identity, and that's going to allow us to replace cosine squared theta. So we're going to rewrite this whole thing, but instead of cosine squared theta, it's going to be 1 minus sine squared theta, and then the rest of the problem isn't going to change. So plus 5 equals 0. Okay. I'm going to distribute here. So it's going to be 2 minus 2 sine squared theta minus, and again, the 13 sine theta and the plus 5 isn't going to change. I'm going to collect up some like terms. So negative 2 sine squared theta minus 13 sine theta, let's see, plus 7 is equal to 0. Now, I'm not a huge fan of the fact that this is negative as my leading term. I could leave it as it is. I'm not going to. I'm going to go ahead and multiply every single term. I know I can get that out eventually. So every single term by a negative. And so all the signs are going to switch. So this is going to become positive 2 sine squared theta plus 13 sine theta minus 7 equals 0. Now at this point, we're going to factor it. Now you could do the u substitution that we did in the last video. I'm going to be lazy and not bother. So I'm just going to do 2 sine theta here. I know that's going to be a sine theta here. Let's see, that's going to be a plus 7. That's going to be a minus 1. Let me do a quick double check. And those are absolutely the right factors. Okay. So now I've got this whole thing in factored form. I have the first factor here. So 2 sine theta minus 1 equals 0. And then separately, I have sine of theta plus 7 equals 0. So let's deal with the first one here, which is this kind of problem written in red. So let's see, we'd have the sine of theta is equal to 1/2. So I added 1 to both sides, divided by 2. If we think about the ASTC chart, we would have, let's see, ASTC. Where is sine positive? Well, sine's going to be positive in first and second quadrants. So first quadrant, I'm just going to go ahead and use the reference angle. So sine is 1/2 when theta is pi over 6. And then I want to also get the angle in the second quadrant that has a reference of pi over 6. So that's 5 pi over 6. And how did I just do that? Remember, this is going to be pi minus pi over 6. You want to count backwards off of the 180 or pi, off the x-axis. So that's the first one. Let's deal with this one. So this is going to be the sine of theta is equal to negative 7. Negative 7 is not in your trig chart. Positive 7 is not in your trig chart. And hopefully you recognize that that's not possible. So there is no possible solution here. And what I'm going to give you is a note here. This is not possible because the range of sine theta is from negative 1, it's negative 1 to 1. Okay. if you remember our graphs, this sine curve oscillates. It's a periodic function. It's called oscillating. It oscillates between -1 and +1. It's not possible to have a sine value outside of that for these problems. So when it says sine of theta, we haven't enlarged this. We haven't made it, it's just the sine function. It's the basic one that has an amplitude of 1. That doesn't make any sense with a -7. So this particular part cannot give us any answers. They're considered extraneous answers. No, they wouldn't even be considered extraneous because there aren't any. It is outside of our domain or our range in this case, range for this one, so you could not have any answers. So that's problem number 11, and I wanted you to see there's a couple of things happening here. We had to replace cosine squared so that we could make this equation be all in terms of sine, and then we can solve it. And half of our answer here, right, this part right here with this sine of theta is equal to -7, will not give us any answers. So this factor doesn't give us anything. I'm going to go ahead and slide over to number 12 because number 12 has also got some weird things going on with it. Number 12 has a radical. And we want to actually isolate the radical. So my radical is right here. This is going to be a little bit weird, but because the radical itself is negative, I'm actually going to move this term to the right side. So this equation is going to turn into the sine of x is equal to the square root of 1 minus 3 sine squared. I don't know why I just did that. There's the x. Okay. To get rid of the radical, I am going to square both sides. On the right side, square and square root eliminate each other. On the left side, you're going to have sine squared. I keep trying to write a theta, but I know it's x. So sorry about that. 1 minus 3 sine squared x. I'd like to collect all of the sine squared x's to one side. So I'm going to add 3 sine squared x to this side, well, to both sides. So 4 sine squared x is equal to 1. And I want to solve this. So let's go ahead and divide both sides by 4. So sine squared x is equal to 1/4. We actually did a problem just like this. It was at the I think it was on the first video. So at this point, I'm going to actually, it sounds weird, but I'm going to take the square root of both sides. So we're going to get the sine of x is equal to plus or minus 1/2. All right. So let's take a look and see what's going on here. Unit circle here, so ASTC. Let's see how thick that line is. A little bit too thick. So let's go positive sign is going to be first and second quadrant. So that's going to give me x values of, let's see, first quadrant would be pi over 6. Second quadrant is going to be 5 pi over 6. So first quadrant is pi over 6. Second quadrant, this would be pi minus pi over 6. So that's the first two. But we also have negative sign values. Oops. Try that again. There we go. Negative sign values are going to happen in the third and fourth quadrants. So let's figure those out. In the third quadrant, I'm going to take pi plus, pi over 6. And fourth quadrant here, this is going to be 2 pi minus pi over 6. So those two answers are going to be 7 pi over 6 and 11 pi over 6. Now, I would love to tell you that you are done with problem number 12, but then I'd be lying to you, and I don't try to do that too often to you guys. The problem is, because this equation has a square root in it, you have to check your work, okay? It is entirely possible that we have answers that are considered extraneous solutions, and the only way we're going to know that is if we check what we're doing. So off to the side here, and by the way, there's 4 answers. You have to check all 4 of them. It's possible none of the answers work. It's possible all of the answers work, or any, variant between those two. So you have to check everything. So I'm going to start by checking pi over 6. Now what that means, I'm going to go back to the original function here, and every place I have an x, I'm going to replace it with a pi over 6. So sine of pi over 6 minus the square root of 1 minus 3 sine squared pi over 6, and that's supposed to equal 0. Now, I'm going to try and do this with Desmos. And of course, I don't have Desmos set up, so give me a second to go grab Desmos. It always takes a few seconds for Desmos to load. Love it. Okay, so I'm going to split screen back with Notability. Maybe. There we go. Okay. Quick double check. Desmos is in radians. That's its default. And basically, I'm going to type in this entire left side in one shot. I just want to make sure I put it in correctly. So I'm going to go to functions. I'm going to grab sine. This is going to be pi over 6. Get out of that function. Minus, I need a square root of 1 minus 3. Let me grab my function again. Sine. Now, this is going to be a little bit backwards, but it's pi over 6. We're going to go ahead and do that. Whoops. Let's not do that. That. And then square it. Now, this is where you have to know the calculator pretty well. This mess is a teeny tiny little itty bitty negative value. It is so teeny tiny and so weird that basically what you're going to do is you're going to say, by the way, if you remember scientific notation, this decimal point right here between the 2 and the first 7 is going to move 16 places to the left. So when I say this is a teeny tiny little number, it is a teeny tiny little number. In fact, it is so close to 0 that your calculator is trying to tell you it actually is 0. So that answer checks out. All right. I don't know why it has issues with this sometimes, but sometimes calculators just do that. So I'm going to go ahead and check my next answer, which was 5 pi over 6. So check 5 pi over 6, which means I'm going to do the same thing. So 5 pi over 6 minus the square root of 1 minus 3 sine squared of 5 pi over 6, and I'm hoping that equals 0. Now let's see if this one actually turns into 0. The other thing is I'm going to be a little bit lazy, and I am simply going to scroll back through the problem here since I wrote it once and not really want to change everything. There's my 5 pi over 6, and there is 5 pi over 6. If I hit enter, it's the same answer. So again, we're going to assume that this is 0, and 0 equals 0. That checks. Okay, so that tells me these first two answers are good. Separately now, I'm going to go ahead and check 7 pi over 6. So check 7 pi over 6. So sine of 7 pi over 6. And you'll notice it's the same equation each time because we keep checking the same thing. All right, I'm going to go back to the original here. I'm going to go ahead and delete out the 5, replace it with a 7. Let me arrow over far enough. There we go. Delete out the 5, replace it with a 7. Okay, this one's actually really easy to tell. That -1, we're getting the answer of -1 equals 0. I don't know about you guys, but that's not true. Because that's not true, I know 7 pi over 6 is not my answer. It's just not possible. We've got one more to do, which is we're going to check 11 pi over 6. And again, same thing here. So sine 11 pi over 6 minus the big old square root. And I never write that square root large enough. Oh, but of course this time I did. Equals 0. All right, so I'm just keep going back to that original problem I was writing there. There's 11 pi over 6. And let me go ahead and scroll to the right. There's another 11 pi over 6. And I keep getting this answer of -1 is equal to 0. I know that's not true. So that tells me that 11 pi over 6 is also an extraneous solution. So let me slide that over. So when you have those extraneous solutions, you literally just cross them out. Clearly I've crossed them out. And I'm going to box up the ones that I know that do work, which is pi over 6 and 5 pi over 6. Be careful with these. All right. Radical equations like this, you absolutely have to check. That is the only way you're going to know if you have extraneous solutions or not. The other problems on this page, I'm going to just go ahead and put into the key. Let me know if you have any questions or concerns if about any